When we talk of the AC circuits, we will be having AC components like resistances, inductances, and capacitances. We will take their behavior in the AC as well as the DC one by one. Let's talk of the behavior of resistance in AC. We will be having a circuit with an EMF source that is an AC. E is equal to E0 sine omega t, and R is the resistance of the resistor here. So according to Kirchhoff's law, when the circuit is complete, the current I flows in it, and according to Kirchhoff's law, E will be equal to IR, or we can see E minus IR is equal to 0. Now we have that E is equal to IR. From that, I will be equal to E divided by R. Now, E is the instantaneous value of the EMF, and that is equal to E0 sine omega t. So, we will be having E0 sine of omega t divided by R. We know that E0 is the amplitude or the peak value of the AC. So, E0 by R will be the current, and that too will be the peak value of that current or amplitude of that current. So, from there, we have that I is equal to I0 sine of omega t. So, from here, we deduce that the behavior of resistance in AC as well as DC is the same. That is the reduction of the value of the current. So if R is low, I is more. If R is more, I is less. So the behavior of resistance in AC as well as DC is the same. Also we have that here E is equal to E0 sine omega t, I is equal to I0 sine omega t. That means the phase difference between the EMF and the current in a circuit having pure resistance only is 0. That means here we are having the sine waveform, here we are having the sine waveform. So the waveforms are the same, and let us discuss about those waveforms and the phasor diagrams. We have that here. This is the sine waveform. This is E is equal to E0 sine omega t. The current will have a same waveform, but remember, I is equal to E0 divided by R. That means E0 divided by R sine of omega t. That means the peak value of the current will be less than the peak value of the voltage. So the waveform will be the same, but the peak value of the current will be less. So we have got two waveforms. This blue one is of the EMF and this red one is of the current. So here the phase difference is 0. Now let us discuss about the phasor diagrams. In phasor diagrams, we see that we have got two axes. One is x-axis and another is y-axis. Now we have the waveform of EMF and the current. We have got E like this. This is peak value of E0. This is making an angle of omega t in anti-clockwise direction, as the phase difference is 0 and the amplitude of the current is less than the amplitude of the EMF. So the angle will be the same omega t, but the amplitude of the current I0 will be less than E0. So this is the phasor diagram. Here from this phasor diagram, we should see that the phase difference between I0 and E0 is 0 because both are making omega t angle with the x-axis. Thank you.